Hello, everyone. Welcome. So today we're going to do part 2 of the discussion of the mini project, KNN. So hopefully this will wrap up that discussion. Next Tuesday, I do plan to start neural networks. We'll start with performance metrics and everything. And then all the project is assigned. I'm giving you guys, let's say, a week to so next week, show me where you are with the project. And then let's do it like in 2 weeks. Okay, so I think I misspoke, but on Tuesday, and I had said initially that you would show me, I think, where you were. So do that. Okay, so a week from today, be prepared to show what you have done, right? Hopefully you're done. I think it's not as difficult as you imagine, right? I will provide more code today. And basically discuss more things. But yeah, let's kind of like a pre-demo and a demo, right? Kind of like that. So in 2 weeks, definitely this would hopefully be done. And I've seen actually some of you what you've done, and it's in good shape, right? So, but today I'll cover the second part of this, which is gonna be the annotation, right? So what is annotation basically? So this is the challenging part that you guys visualize right now. You have data, but you need labeled data, right? You need for whatever it is. So this is actually really difficult. And, I give you the code, right? I gave you the app. So you got all of that. That's not really expensive to get. What's you're finding expensive to get is the data for the application that you need. So this actually justifies something very interesting. So you hear nowadays all the time that everyone is collecting your data and selling it, right? You hear this all the time, right? So Google ads, whatever, they're taking all your private data and then they sell it. Why do they do that? Because there's people like now you're on the other side of that, right? So before you were like, people are taking my data, but now you're actually the developers. You're building something, and what do you need? Data. And maybe it's something that is very, very lucrative to you, or it's something that you want to get a good grade on your assignment. Whatever your justification is, you now are at the other end of it. And you're starting to see that, now there's some value to this data, right? So if some friend of yours came in and said, hey, here's the data for this project, give me a hamburger, you may just buy that burger, right? You see what I'm saying? Now imagine if you're a company like Facebook, etc., they make a ton of money out of it. So this is why data is so important, right? You need it for the application. You see that? All right, so today we're going to cover the annotation part of this. I think I've given you the app and KNN, and I believe you guys have that down, right? So the question is now the data. So I have a few additional resources for this that we're going to discuss today. So basically, you can see this is the homework repo. So I'm going to, in the previous video, or like lecture, you saw that we went over the entire tool, right? So I showed you, given the images, you load them like this, boom, you do the KNN algorithm, and then average them out. But the question that was raised there was, what do you do about these images, right? You need to collect them. So what's the process? So that's what we're going to address today. So I'll start here by clicking on this link, right? That takes us basically to where I said. So the instructions on how to do the GitHub pages, I already demoed this, but the instructions are there. As I said, this, you can just do it to practice. It's not required for the project, but this part is, right? Understanding KNN and the context of deploying it to the website. I've already demoed that as well. Okay. Why that happened? Oh, it shut off. Sorry. Does that all the time. Are you back? Okay. And basically, the app that you guys are building is this one. Where I provided already that the intuition is that this is the only file that you need to develop, the index file.html. Today, we're going to talk more about this, which is processing your data a little bit more with the Jupyter Notebook. And then, if you remember, we talked about these two CSVs, which are going to contain the data. The trick is to have, right, the images flattened basically in one file where you would have an ID associated with it. And in the other file, we have that ID and the conditions vector. That's the annotation that you need to create, okay? So we'll talk a little bit about that. Now, so we've discussed all of this. And you've seen the application. When you click on it, like over here, it generates basically something like this. So just to kind of re-emphasize, we have two sets of data or two vector spaces. Basically, one vector space is the conditions, which would be represented by, in this example, by these 10 text boxes, okay? So it's just to give you some data, if you were, had 200 images, then the condition space, this one would be what? 200 by 10, correct? Do you see that? And the image space would be what? 200 by 784. If it's images like MNIST, which are 28 by 28, but flattened. Do you see that? Now, one thing that you need to add to that is the ID that matches them together, almost like in SQL databases. So technically, then it would be 200 by 11, right? To account for that additional ID. And in the other file, 200 by 785 to account for that additional ID, which is what you can use for the mapping. Does that make sense? So these are the files, okay? And remember, when you press the generate button, these vectors, the vector space of 10, right? The 10 features, 10 dimensions is where you actually, you enter this point into that space and look for the 10 closest samples. But instead of retrieving a label, like we have said before, with the original KNN, you retrieve the ID or the file name, either one is fine. And that then allows you to grab the corresponding images. Let's say you grab the 10 closest images and you average them on a pixel-wise basis. What does that mean? You grab a vector, let's say, of 784, another one of 784, another one of 784. When you average that, what do you get? A vector of 784, right? So if you had 10, what does that matrix look like? 10 by 784. Do you agree? And now average that on a pixel basis, and you get the result 1,784. 1,784. Make sense? Any questions about any of those ideas? All right, so I think now, hopefully all that is clear. So then you're like, all right, but how do I, and then just to finish, that 1,784 needs to be unspaghettified or unflattened, right? To become 28 by 28 or whatever dimension you're using. Keep in mind that since we're not using neural networks for this one or anything like that, you can use slightly bigger images. Okay, so I know I've said in neural nets it's like 300 by 300, and that's true. That's just because of like, we're gonna the bigger the neural net, we're going into a GPU and just running out of resources. But here in this example, it's all basically the limiting factor is the RAM on this web browser. So basically, it could be a larger image. Yeah, Henry.
So 28 by 28 isn't big enough?
I mean, you can do whatever images you find, but I think for this project, you can go with a little bit bigger because the resolution of 28 by 28 is not great. So, but that's MNIST. But it's only handwritten digits. So it's like it's really just a 7, a 3, so you don't need that much resolution. But for this project, you're not really limited by all the operations in deep learning, so your images can be a little bit bigger. And you can see the dimensions I use here, and I think 400 by 400 should be perfectly fine. The limiting factor will once again be what? GitHub. GitHub only allows you to load files that are 25 megabytes. So if you have RGB, I was discussing this with Aiden, have 3 files, one for the R, one for the G, one for the B. That actually, it makes sense intuitively to break the file like that. Got it? Any questions? All right, so all of these were concepts from Tuesday. Now we're just going to move on to the last part of this, the data. Data is king. Data is worth a lot of money. Data is hard to come by. Okay, and this, if you do data science, machine learning, this will be a challenge all the time. Because it's not just that, you find the data and then you have to put it in the format that is required, right? So we have a few of the tools here to discuss. So if you notice in this, the same link here, now there's a folder called GIMP. I don't know if you guys have heard or used this, but GIMP is a nice tool for image processing written entirely in JavaScript. So the nice thing about it is it's web deploy. You can deploy it on the web. So obviously we can do a lot of operations in NumPy, in the Jupyter notebooks, etc., right? And that's great. You can do it that way. But at the end of the day, since you're deploying an application, you still may need to do some of these operations in the browser itself. You guys see that? So that's why I'm giving you some of these resources. Now, Aiden actually found this really nice tool also, and I thought I would recommend it to you guys. It is called Image Resizer. So it's a web kind of a tool. So your classmate there, right? And it's basically that tool over there. You can use that tool for annotation. Do you see what I'm saying? What the tool allows you to do is it allows you to load a file. You have a folder in your desktop of all the images that you've collected. I don't know, you were really interested in Marvel characters, let's say, and you went and you downloaded all the Marvel characters that you wanted, but they're in different sizes, right? Because that's how you're going to find pictures on the internet. Does that make sense? Well, this tool now, you put all your images, let's say 200 Marvel characters in a folder. Image Resizer then allows you to select those images from the folder and load them up in this web-based application. Does that make sense? And then you can resize all of those images to a fixed size, which is the key condition that we need. Any questions? So you can say 300 by 300 for all of them. Got it? So this is a tool that you can totally use and just use it for your annotation. You can save the files in there, right? You could change the name of the files, right? Or did it use the same file names? Do you remember?
I don't remember. I know it put it in all the files into a folder that's the same, but I don't know if it changed the name of the file.
Yeah, right. So that allows you to resize the images, right? And then you have to figure out how to change the name of it. Okay? Make sense? All right. So you can use that tool. That's one tool. Play with it, and figure it out. So one thing that allows you to take the image, resize it so that they can all be consistent, but you still need to annotate them, right? You need to provide the values that you're going to associate with the images, and you need to think about how you're going to do that in a very manual way or in a more automated way. Okay? So so for those of you that just like to code everything from scratch and not use someone else's tools, Henry, right? There's this other tool that we can use called GIMP. GIMP, I think is how you pronounce it. So it's a very nice tool. Some of my students from the pandas, red pandas, actually, they had used it before. So we've used it before in the class. So I just created a few examples of this for you guys to build this if you want. Literally, effectively, you could basically, your image resizer, you could write your own and deploy it on the web, but now you have control of the code. So I will just today kind of go over that, give you some ideas of how things that you can do, like loading an image and then resizing it, and then just show you some of those demos. You can, from there on, you can decide how you want to approach this. And obviously, as we get to the end of the semester, you may use this again. Because the nice thing about this is it is JavaScript, so it will run on your final app, if you will, in the web. Any questions? So I provided this additional link here. You can see it here. It's called GIMP. And this one just has some additional examples beyond what I'm going to present today, because there are some problems, right? Resizing does not, what does that do? So it might do padding. So that means that you're going to have a lot of like background that it's in black at the top and at the bottom. Is that something that you want for your images? No. So in that case, maybe what you want to do is crop the images, center crop, and then resize. You see what I'm saying? So you have more functionality there. The tool has a lot of things available. Okay. So this is what one of the things I'm going to discuss today. I provided this example, Red Panda. It's a little image. And I have these two scripts basically that I'm going to go over today, kind of how it works. Before we do that, though, I want to go over the idea of the annotation itself. Okay, so you want to think of how do you want to annotate this. So I'll show you first how you would annotate for one thing, and then how you, in this case, might want to annotate for this specific problem. Annotation, as I said, is the process of creating data for supervised learning, which basically means you have the feature vectors, but you also have the labels. So you have a picture and you say this is a cat, another picture that's a dog, and so on. That is annotation, okay? And you do that for supervised learning, basically. So we're going to switch to the whiteboard just to kind of go through this idea of annotation. I suggest start with a few images, not 1,000 and wait until you've done 1,000. Do just a few. This will work with 5 images or 10 images. The thing is, it may not work very well. But I would suggest annotate a few, run it through the app, see what you get, and then keep adding data and thinking about how you can improve. Got it? Does that make sense? All right, so we're going to switch to the whiteboard. Okay. And stop me if you have any questions, please. But this is kind of a more manual process. Okay, so we're talking about annotating a corpus. A corpus is the name that you sometimes give data sets. Okay, there's quite a bit that goes into this, but in general, you have the X matrix and the Y vector, right? So initially, we're going to define that this is going to be just, 100 images. 100 images, so this is 100. You know that the dimensionality of this, I'm going to make some assumptions. You've already resized the images, right, to whatever you want them to be. They don't have to be 28 by 28, but I just remember that. So I'm going to use that. So it's going to be from 0 to 784, right? I've spaghettified them. Remember that you don't have to store the images and convert them while the app is running. Instead, what you could do is store these as CSVs. Remember that? Just remember that you're matching, you have like a column here of IDs. And of course, you would need to have a column here of IDs. Or it could be the file name itself. It really just needs to be some kind of a key that allows you to do that mapping. But in the code I provided, it's numbers, IDs. Okay, so this is pretty clear already, pretty straightforward. To create these CSVs, that's where you use that Jupyter notebook that I provided. So that's what that's for. Okay, so now the question is, remember that for this problem, you've learned that Y is usually like 100 by 1, right? 100 by 1 for the data itself. But for this problem, Y really needs to be 100 by at least 4 or 5. That's because that's the conditions space, right? We're just thinking about the problem a little bit. I'll get to that, but initially, let's just start with this scenario of 100 by 784 and 100 by 1, right? Annotation. So what does that mean? It's very simple. You define a problem. Let's say that you're looking at pictures. So each one of these is now an image of cats and dogs, right? So you have an image, and it's it's cat, right? And then you have another image, and it's some kind of a dog, right? So basically, you have cats and dogs, and you're looking at them. All you have to do is decide, okay, the labels are, what animal it is. So then you're going to say feature 1 in this case is an animal. And then you decide that cat is 0. So cat is 0, dog is 1. And then basically you start annotating 0, 0, 1, 0, 1, 1. Do you see that? You just have to do that for every single one. Okay? That's annotation. Super straightforward. You do it based on your judgment. At the end of the day, machine learning is trying to learn to think like humans, right? You look at a picture, you say it's a 1. You look at a picture, you say it's a 0. Then the machine learning algorithm looks at the same picture and it needs to learn to say that it's a 1 or a 0. That's it. Okay? Now, for the problem that you guys are building, you need to do more, right? You need to have these conditions. So we're going to have one CSV, and it's going to be ID and then the data. So I'm going to call it, I'm going to call this, just to avoid confusion, I know what I can call it. Pixel. Call it pixel. Each column, so P1, P2, all the way to P784, right? That's it. So here you're going to have the IDs or the file name, whatever you want to use, that corresponds for. Okay? Now, you don't have to annotate that. You will just use the Jupyter notebook to take the images and create the CSV, okay? But the other file, so this is one, let's call this file1.csv. The other file is no longer, which would be y, assuming this is 100 by 1. Now it's going to be 100 by however many conditions you decide to have. And I promise you, you'll start with 4, but as you start to improve on this, you'll be like, what if I add, and you'll keep adding things based on your own curiosity. So now you create another file, also 100, also has an ID, right? This is the where you match them. And now this is going to be the condition. So we're going to say file to CSV, okay? Because they're going to be comma separated. And this one, which would traditionally have been the Y, it is now your conditions. So this, you could call it F1, F2, or if it's, because I'm calling them conditions, you want to call it C1, C2, CN. What is N going to be? That's up to you to decide based on the characteristics of what you're labeling. You see what I'm saying? So let's think this through. So you're doing cats and dogs for whatever reason, right? So what are some column names that you would choose? Let's say, and let's define this to be 5, just to have something. So what are, now, it can't be, so it could be anything, but you really have to think about things that would differentiate one image from the other, right? That's kind of what you're looking for. And then you're going to make combinations of. Now, these values in here need to be numbers, but they could be 0 to 1. 0 or 1, actually. They could be 0 or 1. They could be 0 to 1. They could be -1 to 1. Do you see that? One thing I would recommend you avoid is having actual numbers like for C1, it goes from 0 to 1 million. And then in C2, it goes from 0 to 1. Remember, because of the scaling and normalization, you want to normal. If you did something like this, it's not, it does, when you move those scroll bars or whatever, nothing will happen. Just one of them will dominate everything, the largest range. So make it all so that they're all relative, so it's more like sensitive to your changes. Yeah, Henry.
You're basically implicitly applying more weights to like one feature.
Exactly what you said is if you did this, because you would be applying more weight to one feature. Yes.
Because then you just have to like have machine learning algorithms like think, oh, I just need to get this one feature thing right.
Normalize it, yeah. But that's why the best approach is just to normalize it. And normalize it, there's a couple of ways of scaling. It's two techniques, normalization and standardization. But because you are doing the annotation, just do it like that, okay? Choose this as a range. You can start with just binary and then start adding more in there. Got it? All right, so then, now that you know what the values should be of the annotation, pick 5 characteristics. This is really where your creativity comes in, based on the problem that you want to do. You see what I'm saying? So if we're doing cats and dogs, for instance, what are some distinguishing features? Size, I would say, is probably one of them. Size. So you got big dogs and little dogs, right? So, or cats, also. So size. So basically, this is a Chihuahua, and this is a German Shepherd. Do you see that? So what does that mean for the annotation of this column? German Shepherd would be about a big animal, but not the biggest, right? So a German Shepherd probably 0.8. You could choose that, or just say 1, right? For really big. It just depends on how you do this. I'm just saying, pick some that's why I'm saying, actually, just annotate about 15 to 20 initially and run it through the program. And then keep tweaking it until you start to see it do what you want. Okay? Someone had a question?
Yeah, so could like another way, I guess the way you would the weight thing. You have like a range between, I don't know, like the shortest way possible, like the biggest way possible, the upper bound.
Don't call it weights, just call it values. These
Sorry,
are
values.
yeah.
Correct, weight makes things else. And then you just convert whatever is between that range from 0 to 1.
You can scale it after the fact, like annotate it and then scale it. It's totally doable. But you're doing the annotation, like you're the master of this. So start doing that in a normalized way. Don't, or although maybe you want to be very realistic about something and use actual values, but then I do recommend that you scale. Okay? So yeah, exactly. So then the Chihuahua is very small dog, right? So then you could say 0.10. Do you see that? That's what you're looking for. In a vector space now, you'll be able to move size, right? And based on that, you're going to find more towards a German Shepherd or more towards a Chihuahua. And now your goal is what? To maybe try to generate an image that averages Chihuahuas and German Shepherds. What would you get? You see what I'm saying? That's kind of what this is. But you're playing with these values to achieve. Can you achieve that? Get images, 3 images of Chihuahuas and 3 images of German Shepherds, average those and get, yes, definite. How are you going to accomplish that? Through this. Okay, that's why this is where the hard work comes in the annotation to achieve the results. So start with just a few images, about 20, run it, and then keep annotating, keep thinking about the columns that you want to have. Is this clear, guys? Does this make sense? Yeah, yes.
So when we're talking about scaling, should you scale it like locally almost? So if I have a Chihuahua and a German Shepherd is the biggest in my data set and Chihuahua the smallest.
You make that decision, yeah.
Okay, but then there's like a Great Dane, and I don't have a Great Dane in the data set. So
I know.
so I just decide.
You decide based, so it's all dependent on the data set. You kind of answered the question because you don't have a Great Dane, right? So it's never seen. So this is actually a good point. This model cannot predict a Great Dane. Neural networks, as we will see later on, could, because they can predict things outside of what they have seen. But KNN is contained entirely within this space. You see what I'm saying? Like we've defined a space, where the biggest thing is the German Shepherd. So the model cannot say, well, a Great Dane would be somehow bigger because it doesn't know anything bigger than that within this space. Neural nets learn in a different way to where you could increase it and it will try to predict outside. So that's actually a really good point. Got it? Make sense? Guys, do you understand the annotation process? That's what you have to do. Basically, fill this in with values using your human intelligence of what you want and what you see in the pictures. Okay? All right, so if that's clear and I'm not hearing any questions, then now we can go to the GIMP examples and just take a look at what we can do as far as resizing. As I said, yeah, so I'm gonna make sure I do this right. So let me do stop sharing. Then, because I sometimes don't do this correctly. So I think I'm sharing the screen now. Okay. So now go ahead. As I said, one important thing, definitely 100%. You know, Aiden's what he found, image resizer. Go try that out. All right. Download some images and run through it and resize them all. Make sure that they do come out of the size that you want. That will help you quite a bit. The other alternative I'm providing here is GIMP, that, as I said, is a JavaScript tool for image processing. Okay, the nice thing about it is if somebody had asked me, how do I process images? And I said torch vision. That's very powerful. The problem with that is you have to run it in a Jupyter notebook. It's not going to deploy so nicely on the website just like that. This is all already in your app. Okay. All right, so let's go ahead and start playing with these ideas. I'm not, as I said, I'm not going to cover all the details of GIMP, but you can check out this second link here, and it's got a lot more examples on cropping, rotating the images, watermarking them, you know, all kinds of things. All right, so let's go ahead and take a look. So I'm going to download this. I have this red panda image. I think I downloaded this. So this is just students from last semester did that. Okay, so I don't have it. All right, so let's go ahead and download it. So click on redpanda.jpg and you can download it. Okay. Now we're going to take a look at code. So I'm going to go to GIMP library, and I already set up this file, example1. Look at it. So I'll just kind of discuss the basic ideas here. So basically here, there is, you run this first. How do I run this? I'm going to run it first. Okay, so example1.html. There we go. So this is the first example. This just shows how if you wanted to read in the images, like if you wanted to create your own annotator, for instance, you could use this approach, right? So this just gives you a, yep, it opens this, right? The image, I think it's located probably in downloads, I want to say. Red Panda, there it is. And then I just, you know, and that's basically just to load the image. So at that point, it loads the image, and then you can do the processing inside, okay? Make sense? So you can use this tool for that. Now let's take a look at the other script where I do the actual resizing, okay? So let's, that's going to be, and then we'll go over that one. So example2 HTML. Oh, there it is, yeah. All right, so I resize the image here. This is just a standard image available from a URL, and I made it really big. One problem with it though, look at the background here. Do you see that? So this is an issue. Why is this an issue? Because if all your images have this like background, when you average them, that's going to be present, right? So usually then you want to crop, okay? So really a lot of this is getting to play with images, and machine learning, definitely you do that a lot, okay? As we get back into neural networks and we get towards the competition, which is SciFAR10. SciFAR10 is an image data set. Okay, so you will be dealing with images, you know, as that is one of the classic examples in machine learning. All right, so basically then, that's the basic idea. So in this case, I'm just showing you very basic functionality. I have not center cropped or anything like that. Should you do it? It's entirely up to you. But the quality of your images is going to depend on the processing that you do. Okay? Make sense? All right. So now, so you guys have seen, this is a very simple thing. You can hit save image as here and label it. You see what I'm saying here? So this is in fact not as sophisticated as Aiden's analyzer, but you could build your own annotator through this approach, okay? So let's discuss this one. It's manual, it's very slow, but you can definitely do it. So that's kind of what I'm going to discuss today. So let's go into the code, take a look at how this works, and then we can come back again and run it as I'm trying to say that you could run this. All right, so I'm going to, not that. Going to go back. All right, here we are. So we are going to, which is example 2, I think. I'm going to click on example 2. Now we're going to get into the code. I will hit the pencil here so that we can do some edits, just so that you guys can see kind of the process. So basically, it's, you know, as you can see, it's pretty short. And, you know, depending on your coding skills, you could really scale this up to be very impressive, right? But basically, it's a HTML, got the head section here. What's the head section doing? As you probably remember from your 362, or you will learn if you haven't taken it already, you use JavaScript libraries, like, what is one that you use? jQuery, right? Yeah, jQuery, exactly. All right, so you're gonna, you know, just like jQuery or PyScript, now we're bringing in GIMP, all right, which is an open source JavaScript library for image processing. Very important in machine learning for processing the data. All right, then after that, that's the head section. Then we have the body section, which starts here and ends, ends right there, okay? So basically this process, I'm reading in, so there's a heading, hello, then there's the opening script tag and the closing script tag over here, okay? And basically then you invoke GIMP, right? And notice that it reads in the image from a URL. So in that case, I'm pretty sure there's a functionality to read it in from like a file or something. But if you do it from the URL, what do you have to do? Just put the images on GitHub, right? If you put them on your GitHub and Pages is deployed, then you will effectively have the URL to every single image and bring it in. You kind of have to do that manually unless you choose the alternative, like example 1, where you read the image into, so it's up to you. I think this is easier because here you would just, let's say you have 200 images, and they're all less than 25 MB, create a folder in your GitHub, wherever you're doing this, dump them in there, and then you can just put in the URL. Does that make sense, guys? Is that clear? Question? Yeah, please.
The URL to the folder?
Yes, it's the no, it's gotta be like I showed you guys. So if you remember, when you use Pages, it creates like a domain for you. And that domain is going to consist of your username and the word github.io. So that's gonna be, so you see it here, you see that? So HTTPS, your username, github.io. So, but this only works once you've configured pages on that particular repo, okay? Questions about that? Once you've done, and then after that, yes, put the path. So this, if you notice, this probability density, that's a repo name. So after that, it's just a repo name.
So then what that's gonna, is it could read through your folder with all the images on
You could iterate through it, like you could write that code. I didn't. I just did an example of one, but you are correct in that sense, yes. You could write the logic because maybe your naming convention was to say, sorry. Your naming, that's a good question. Your naming convention was example, image 1, 2, 3, 4. So then you could iterate in JavaScript and just change that part and change all those paths. Yes. The way I did it, though, it's very bare bones. And you kind of have to do a lot of things manually, but at least it helps you. It is a poor person's annotator. All right. Any other questions, guys? All right. So let's keep going through it. Okay. So we're going to go back to the code over here. All right. So as I've explained, you load the image from the URL. So that means just dump all your images that you want to annotate and resize into the folder on the repo. You can also crop them, although I didn't crop them. There's some additional steps, like I said, that you might want to look into to create better quality images, okay? So now here you can see, you read the image, Jim reads the image, and then it says dot then, right? And now it basically creates this new variable image, right? Pointing with this arrow. And that's basically what you just read. So that image that you just read is an image here. And if you notice now it says resize image using the contain mode. So in this case, you can use image contain, and notice that I resized it to 1000 by 1500. That's the resizing. So just be consistent here. You're going to have images of different sizes, correct? But they're going to be all resized, hopefully, to be the same size. Any questions on that idea? That's the resize step. Probably before you do the resizing, look in here at the GIMP documentation into cropping and things like that, but I kind of leave that to you to explore. All right, so once that's completed, notice that the next step is this code segment here, and this is basically how the image was displayed, right? So basically, the image is this object, it converts it to JPEG, it converts it to this variable new image. Then if you notice, you just use your knowledge of HTML, right? Document.create element, and you create an element called IMG. That's effectively an IMG tag. You assign it to this variable, and then you say tag.source, and you assign to it new image. You see that? And now you can go ahead and assign. I have a div in here, if you notice, div called image container. So then you get element by ID, that image container, and you append to it the tag. So you can display the image on the website as you're doing. Got it? You could create a button, and that button, all it does is it changes the name of the file and then reads that image and displays it. You annotate it by saving it, and that's it. Do you guys understand this process? If you remember, the example that I had is what? An image and the file name of it had the conditions. Do you guys remember that? So I had like natural gas 50 underscore, oxygen 30 underscore. So those were the conditions in the file name. So this is what I tried to replicate so that this will create images that will fit in the code almost seamlessly. Okay? That's it. I mean, that's literally it. All right, so now I'm just going to do a demo of the basic idea of it. If you have questions, please ask. So really, what is the thing that we want to do? We want to resize the image. So I'm going to go ahead and resize it to 400 by 300, just because. You guys see that? 400 by 300. So I'm gonna now, unfortunately, this takes like a minute to update on the repo. So I probably should have done that like a while ago. But I've changed this. You can, of course, programmatically, like with a text box, you can enter those values, retrieve them. You know, I leave it to you guys to write that in it. You know, the more flexibility you do this, the better, because remember, you're going to annotate something and then you're going to go back and re-annotate it, improve it, etc. So this might be something to play with. And annotate, there's companies that just label. There's a company called Labelbox. Go Google them right now if you want. Don't subscribe because they'll send you emails all the time, but that's all they do. They just like label data and then they sell it. You see, because that's what people want. For AI needs annotated data or things like that. All right. So anyway, so that's done. So I'm going to go back here. No, not. I'm going to go here. Yeah, here. Okay. And I'm going to click on. I actually need, I'm just gonna open a new one. So the domain is your user GitHub IO. So your user GitHub.io, right? Then it should be the repo. It's the get rid of this because this is just a it's in the GitHub itself, but not in the URL. All right. So then you do machine learning foundations. I think it was homework, generative KNN. I think I did have these in GIMP, right? And then example 2 HTML. Do you see that? This is, so it updated already. Remember, this image was huge before, right? And this is the image now. So how do you go about annotating the other part? Hey, right-click works, right? You don't have to write code if you don't want. I mean, you could, but right-click works. And you're looking at the image and you can annotate. You see what I'm saying? So this is you can take advantage of this. So now then you would it's gonna be a JPEG, right? But you want to put in here the annotation. You see that? Be precise, don't make mistakes here. So obviously if you automated this, you're gonna reduce the likelihood of committing errors as you're annotating this manually. Do a copy paste or something at least, and then modify the numbers. Got it? But this is basically the convention that I have in the example. So I'm trying to create that. So we were doing, let's say this is like, let's say you were doing like, you're in interior designing, right? Interior designing is your project. So interior designs. Okay. So you're going to define 4 or 5 conditions. You have to be consistent when you do that, right? So if you decide 5, always do 5. Because then your vector space will be missing axes if you don't. All right, so let's do 4. What are 4 things that we could define here as or actually we don't even have to think about that. You just say C1, or you could start at C0, however you want, and then put the value here, right? So you could do C1. Does this work in file names? It does, right? Yeah. So use some character like that. So now give it a value. So let's say C1 is the number of pillows in the picture for whatever reason, right? So I see 3 pillows. See that? 3. Now, I am here I am not doing what I said you should do, which is to put in normalized data, right? So maybe it does make sense to enter the data like this and then normalize it if that's more intuitive for your annotation, because otherwise you'd have to think, okay, what's the maximum number of pillows that I would have in a picture like this? 10. So if that's the maximum number of pillows that I would have, then this is 0.3, correct? You see what I'm saying? That's kind of it. Use however this is more convenient for you. Either annotate it like this and then normalize it, or normalize it as you're doing it. It's up to you guys. Questions about that idea? All right, so I'm just going to go with this one. Now, underscore, you need something that when you do the split, it's going to give you the different conditions. A delimiter, exactly, a delimiter. So this is your annotation. So then you're going to do C2 dash, how many tables? 2. Do you see that? Now, this may not be the best approach for this, but at least it gives you a start. You do this for, this is taking me a while, but once I get this, done this like 5 to 10 times, it'll take me what, like less than 30 seconds to annotate it. So think, if it takes me 30 seconds, I can annotate 2 images in 1 minute. So how many, that's 120 images in an hour, and so on. This is how annotation works. You really start to think of the number of hours. You can go hire people on Mechanical Turk, give him images, have him annotate it for you, and that's a thing. Do you see that? Okay. Mechanical Turk, if you haven't, it's a service of Amazon. Go ahead, sir.
So then did you annotate like this for all the images in your example?
That was given to me. So the data was given to me. So
Somebody did-
people, it was done by people that know about the physics of furnaces.
So at the end of the day, somebody's doing, like, if you get it from online, somebody's entered that.
Like editing the name of the file.
Well, they didn't do it like, I built this for you guys. They are US Steel. I mean, they, yeah, they have a few more resources.
Okay.
Yeah. So, but that's coming from just physics, and it's something called computational fluid dynamics. It's like science, engineering. So that's how they generated that and the images. But for us, I was trying to think of a cheap annotator, and I think this would work, although it's tedious maybe, but it will work. You're gonna be putting the annotations in the file name, basically. Does this make sense, guys? You have to be consistent, right? So we said 4. So I said, okay, so we need to do 2 more. C3 underscore. No, sorry, this should be dash, right? Dash. And that third value is going to be, what would it be? The number of plants, 1. Perfect. And then let's do another one. Let's think of something different this time. Let's say like you're an interior designer of homes. That's like a very modern, let's say, and modern versus like family versus like Turkish. Yeah, exactly. That's a good one. Yeah. There's Turkish, there's classical, there's family, that kind of thing. You're going to put in that information in there. So then you need to have a scheme for that, like almost like a categorical thing. And you could say, oh, Turkish is like 4 or 5. Do you see that? Again, I'm not following my rule of normalization.
I was about to say.
Yeah, I agree. So you see, like my brain intuitively does not want to normalize, just wants to do this. This makes more sense, but then later you need to normalize. Okay? You need to agree also. You can't on the fly, like after you've done 60 of them, decide to add a new category. You can't do that. You got to fix the categories initially, go with that, or restart, because you can't have those inconsistencies. Does that make sense, guys? And this is it. That's how you annotate it. So now you go ahead, basically, we finish, right? It's in the name, the annotation, so you can click on save. Done. And, you know, I didn't write any of this code. It was just basically, I think it downloads, it goes to the downloads, right? 99 to go. Hey, it's welcome to data science. That's all right. So let's go to downloads. I think that's where I put it.
That is right.
No, maybe I put it on desktop, huh? Oh, here it is. There it is. Perfect. See, that's your product. This is something that you could go out and sell. Nobody will buy it here, but my point is Facebook has billions of things such as this. And that's why they can build the models that they can build, and that's why they make so much money. Yes, sir. Please.
So that's a popular thing to do when you're dealing with image classification, is to name the file the attributes.
This is one nice approach, yeah, because it's contained there. What I like about this is I don't have to go look for this in another file and do the mapping and all that code. It's right there. So when I'm getting the image, I'm also getting the label. So I like this approach. Yes.
But you have to name the image.
Sorry?
You have to name the images.
Yes. Oh, that's a good point. So what happens when you have similar conditions in the image, right? That may be what you're thinking. Add one thing in there. It was initially file one. Leave that in there as file one. That's actually a very good point that I made a mistake there. So have one thing that ensures that it's unique, but it's something you can just get rid of. So how do we? That's a very good point. Just click on the name, right? Yeah, there we go. Yeah, thank you. So yeah, exactly. So here, because you're gonna do like a split on underscore, so just the last one, you can drop it, but make sure it has the unique name, possibly the initial name, because you're gonna be loading these. Oops, sorry. File one. So when you load the image from the URL, just have another little div in there and just show the name. And that way, when you're annotating, you can put this in. Now, as I said, you can automate this as much as you want and make your life easier, but even this will work for you to annotate your data consistently. Got it? And then at the end, you're going to have this data set of, let's say, 100 annotated images. We can take a look just to confirm that we did everything right. So I'm looking for properties here. So let's look at properties. And if we look at, I believe, details, you can see it is a 400 by 300, which is the thing that we were trying to do. So the images are resized. You could also crop them, do all of that, and they are labeled already. And now once you finish this process, what are you going to have? A folder of these images labeled, about 100 of them. And now, hopefully, that Jupyter notebook works. So that we can move on to the next part. Did this make sense, guys? Can we move on to the next part? Do you all understand the annotation process? And again, this is why data is king. This is why Facebook, Google dominate this thing. Because you spend how many hours a day on social media loading images, writing comments. I do the same. Writing comments, liking, thumbs up, little smiley face. All of that is a tag somewhere. I guarantee you, if they can use it.
This is why you should not do something.
This is, well, this job that I just did, right? This job that I just did. The 2 hours that you're going to spend, and you're going to maybe like be angry that you're spending all this time doing this annotation, just keep in mind that that's work that you did, and now compare that to what you do in social media. It's the same thing. So it's basically free work that you're doing for Facebook and Google and YouTube. So all of you think about it, are like working for them, and they've like tricked you into doing it for free, and to give away your privacy also, because it's capturing what you like. Like it's going to say, I really like traveling to this area. So you're giving away that knowledge, and they go probably as far as also recording your IP or something. So they know where you are. Does that make sense, guys? Any questions? All right. Oh yeah, please, sir.
For the images and stuff, are we gonna need like similar, so say if you're classifying cars or combining cars, do they all need to be side profile?
Yeah.
Not,
Yes, exactly. That's something that's really for your application to be good. You have to make some assumptions. So for instance, the example I gave of the passport photo, right? So they're all the same, you know, almost the same background. You're kind of filling in the same amount of area. So if you're doing cars, maybe all cars from the side at least. So you see the two, you know, left side or right side or something like that. And that way you can design a car that has never existed before. Like what if you took a Tesla and a pickup truck, or a Tesla and a convertible, or you know, something like that? What would that look like? And although it may look terrible, there may be something in there. It's like, huh, that actually may not look that bad. You see what I'm saying? So that's kind of the goal. Yes.
Adding on to that, like a side profile, like if you have like a portrait image of like
Yeah.
an animal, for
Mhm.
example, would the background color matter?
Everything matters because you're just averaging. So every pixel matters in this.
So would you recommend maybe like making, like entering all the photos in which all the, like you make the background white, for example?
You can use Gim for that. That's why I'm giving you that library. Or you could use Torch Vision. You can use tons of tools, right? I'm giving you one library because I did the example with GIMP, and so you can add more to it. But if you want to get really sophisticated, you could use something like Torch Vision, and that will definitely, it's like PyTorch's vision processing thing. Images are so important in machine learning that there's like the thing that does deep learning, and there's an equally like important library for just the processing of images. There's a lot of things. As you said, the more you do those things, the better your results are going to be, for sure. Any other questions, guys? So this made sense, right? So you all now are not like terrified of this part. You all know what you need to do, right? You know how to annotate it. You know that once you do this process, if you spend time, right, Henry? If you spend time on this, you're going to end up with 200 images with the labels and everything. Don't do 200 initially. I do think start with like 30, run it through the app, and then keep like, it's iterative. Keep going back, keep, you know, improving it and so on, okay? All right, so if that's settled, then we are at a stage where we can assume we've got the annotation. So we created 100 to 200 images. They all look like this one. They're all in a folder. What's the next step? So the next step is we need to convert these images into the CSV files that we're going to upload, because we're not going to actually store the images, although you could. We're not going to store the images on GitHub. We just want to have like one convenient CSV that does everything. Remember, if this gets too big, you can always just break it up, right? Like, you know, first 25 images in one file, then 25 image, the next in another. Just make sure the IDs are correct, because you're going to build a NumPy matrix in the code itself of the 4 files. We did an exercise to this, right? What was it? Problem 1 of the NumPy examples. You guys remember? Concatenation. You took a matrix and another one, you concatenated them. Well, that's what you would use that. You see that? All right, so let's go ahead now and switch to the Jupyter Notebook, okay? And we can just describe it. I don't think we need to run it, but now we have everything consistent, right? So we have a folder with all the images. They're resized, and they have the conditions in there. So now we just have to read it into a NumPy, and then write to CSV, and then we should be done. So that Jupyter Notebook I've already provided. Let me just make sure this thing's working. All right, so we can go to here. So we're done with this. This is your annotator. Now go to, I think we can close this one. You have to, okay, so I have it, I did move these files to the like the course repo. I still have that in the other repos. So you can, but it's this link here. Click on that. It's gonna be PyTorch, the PyTorch. Okay. So that's what I was looking for. So if I forget, I'll try to add the Jupyter here, but you have everything self-contained. But if I forget, I'm stating right now that Jupyter is just in the PyTorch repo deployed to production. Okay. So let's go ahead and go there. So we can go to the root and then this one, PyTorch, deploy to production. Okay. We will, I mean, this is the second stage of this course, so we'll be using these once we get into neural nets. And then it should be in here, classify images. Actually, I'm sorry, it's not in there. It's in probability, it's in this other one, this one here. Yeah, okay, I need to, let me do this. I'm gonna add a link because I'm getting confused myself. So it's gonna be, I remember now. So go to yeah, I'll add the link, hold on. That Jupyter is here. Yeah. It's this one here. Okay, so I'm gonna copy that. Okay. I'm copying it right now. Full copy. Now I'm just gonna go to this. Do you see that? This is familiar, right? So these are all the links to the GitHub pages, NumPy examples, generative KNN. I'm gonna add a new heading here. Just gonna call it convert annotated images from, into or to CSV. Does that make sense? And I'm just gonna add the link there to the Jupyter. Okay, you can always find it because you're gonna be looking for this link. It was actually right there, but I'm adding it as a second thing. All right, so I'm gonna commit the changes. Okay. So there it is, convert annotated images to CSV. Okay, so this should be the last part of this to create the files. So if we go back, remember, to the table of contents in Brightspace, you look for the mini project here, you click on links, and it takes you to where all the links are, which is there. Got it? Everyone with me? Everyone with me? All right, so let's go ahead and click on this one. Okay. All right, so we had started talking about this Jupyter notebook. Remember, this Jupyter notebook basically starts with a folder and it ends with generating the 2 CSVs. Then those 2 CSVs would go to your deployment and that's it. You're done with everything. Any questions? All right, so let's go over the code. So you can see here, the last part, save data for deployment. basically you create a conditions CSV, and you have this one IDs train, which is the other one basically. Okay. So just printed a lot of things here. Or actually this one, this just, yeah, 2 CSV. This is probably the file. You'll have to kind of, because I have 3 files in there, but I just used 2. All right, so let's go over this, right? Got the libraries. This is the path that I use to load the images. So I just called it images new civis. All right, and but that's going to be where you have your annotated 200 images. Got it? So it starts there. Then I just did this glub path, look for the JPG. So grabbing all the image files, name JPG. Okay. You may find online some PNGs and some JPGs. Read the GIMP documentation. I'm sure you can do a conversion of any type of image to a specific one, such as JPG. Okay. To keep it consistent with what I have here. Here I'm just printing the length of it. This is just a trick that I did to show the data. Like if you want to see on a sample basis what all your data looks like. So here you can see this for this problem, it's all pictures of furnaces with different coloring schemes. This is black and white. Okay. Again, now when we looked at this file before on Tuesday, it seemed like very confusing, right? Now it starts to make more sense because I've annotated the files in a similar format. You see that? So you can print, what I'm doing here is I just printed examples of what files look like so I could remember, okay, this is what the files look like, but it's basically the same idea. You can see here, I've actually printed the actual names as I had them, right? So Nate, I think it was, right? You brought this up. We needed to include that little last part to make them unique. In case you have 2 images that are different but have similar conditions, then you have a conflict. Okay, but otherwise they're separated by underscore, and they would be like hydrogen 2 or H2O. I don't know what that is. NG is probably natural gas, so you can see it's 90, or 0 natural gas, or 40. You see that? That's what matters. That's the value. Notice these are not normalized actually either, right? But I do recommend you normalize them. I assume I normalized them. Maybe I didn't and it still worked, but try both. At the end of the day, one thing about machine learning that I should say is you measure performance, right? You measure like how good is our tool. But in generative models, which is what this is, how do you measure performance? We're doing a qualitative analysis, right? We're basically, what are you going to do? Let's say Henry's going to present his project, in a couple of weeks. We're all going to look at it and either be impressed by it or critique it or say, you know what I mean? And that is not that's a qualitative analysis because what's the metric that you use for generative? Do you see what I'm saying? Like, how do you know when ChatGPT, you ask it a question and it gives you an answer? How do you know that it's a good answer? You basically look at it and you're happy with it or not, right? Or there's some metric for it. Yeah.
Basically making another model that basically detects whether or not
Actually, you can do that. That's called a BERT scorer, and that actually exists for sure. Totally exists. Or there's actually just metrics, like the metrics, F measure and all that. There's a whole set of metrics for generative models. For instance, like translation, there is a score called the BLEU, or blue score. And it basically reads a translation from one language to another and assigns a score to it. So the metrics do exist. We're just not doing it. And especially for images, I think it's hard. You see that? But really, if we were doing a competition of the best generative KNN, we would need to have a metric that everyone needs to run on their images, and whoever gets the highest on that metric wins the $1 million, that's the prize. That's how a competition needs to work. A qualitative analysis is not fair. You know, some people would get angry for sure. Would say that mine is way better, you know. And so, yeah. And so this is really important as we get into these generative models. You still need to have metrics, but right now we're kind of keeping it very basic. So we're just going to do a qualitative analysis. Okay. All right, guys. All right. So let's keep going. I think we can wrap up soon. So basically here you can see we've got now the values, the annotations in the file names themselves. You can see now that I have this nice little function that grabs. Now you get why there is there's this function called label function 2, which takes in the file name. So when I read in an image, I grab the name of it and I pass it to this function here. So you guys can probably use this similar function and just tweak it to your own needs. So what's happening here is, first of all, fname.replace, what's it doing? Just replacing the full path with nothing. Okay, that's pretty straightforward. What is this one doing? Replacing the .jpg. You also don't need that. Do you guys see that? And then I'm doing a split on underscores because that's how I annotated that I wanted to separate my data by underscore. Does that make sense? See, this is why I really wanted to do, where I got stuck on Tuesday and I really needed to do that annotator before this today. So now all of this makes sense to you. All right, and then once I do the split, I generate this variable called temp name, which is basically just a list that now contains C1 and the value, C2 and the value, and you conveniently can go ahead and process the data. Okay. So you can see here then, this had 10 values. So I created Y0, or it had 11, I guess. So Y0 to Y10, right? So this should be 11 things, I think. Notice that yours too will have this problem. Yours will say C1 and then the value, right? If you do that annotation. So you need to get rid of that C1 because you don't need it either. You just need the number. But just you need to remember that C3 is this variable, C7 is this variable, and so on. Got it? Any questions about that idea? All right, seems like it's clear for everyone. So you do replaces, and then now Y0 to Y10 is basically your vector. And notice that what I have in there is the F name, right? And then the values themselves. So I have a string, and then I converted the numbers to float also, if you notice, they've been converted. Okay. All right, so this function just basically takes the name and retrieves the data for that image. Okay, that's basically all that's happening. Then I have a for loop here where I'm going to keep two lists, a list of the images themselves, which is the data contained in, and then the label vectors, which is the name I use to reference the conditions, basically. So now we are going to, remember I said that we bring in PIL. PIL is going to become an important library that you're going to see a lot in machine learning in general, especially when you're dealing with images. You always see PIL. The PIL image, it's, I think, the native Python image processing. Python image processing library, like PIL. That's probably the name. Okay, so I don't even remember if you have to install PIL. It may already be. You don't?
I was using it.
Yeah, so it's already there, right? Yeah, perfect. Yes, perfect. All right, so you can use the PIL image then. Okay, we went over this. So now for image in all paths, so we have to see what all paths is. I think it's that thing from Glob. All paths, path subset. It's basically. Yeah, it would be the list of all the files. So I guess it's this one. I think this is just randomizing all the images, if I remember correctly. So seems like that makes a lot of sense. So this is just taking the images as it read them and basically randomizing the list. Since I'm not running this right now, I can't really print shapes and things like that. But I'm sure if you print shapes, you'll see that it's doing it. All right, so this is the list then basically of all the images. So remember, it would be like the path and file 1 or image 1, 2, 3, all the way to the end. So we iterate through them one by one, right? We've got image name, we've got the full path, and then we do image open, and now we retrieve from the folder that image, and we officially just loaded it into Python, okay? So the image is in my image right there. You guys see that? Questions? All right, once you do that, I can resize them here, so there's that. If you need to resize them again, you can. I think this just, yeah, I resized them there, so I guess you can do that there. So try it. That's what I will say, but you can, now that I think about the logic, this would also work. Keep in mind, you can see here I was playing with the ratios, okay? So what I mean by that is, if you know that the images are originally 200 by 400, when you resize them to half that, what would you do?
Keep that same ratio.
Exactly, keep that same ratio, right? So you have to maybe multiply by the factor and make sure that you don't get like fractions or things like that. So do it in things that give you even numbers, okay? So here you can see I'm doing probably the images were 1400 by 390. I multiplied them times 0.2 to figure out what the resizing parameter should be. So definitely maintain the aspect ratio of the images. Now, if you did this already on the other annotation tool, then probably you don't even need to resize them because they're all going to be the same size. But you may find this convenient to have later. If they are color images and you don't want to do color, although I think it's doable, just make them grayscale. That's okay for the project, but obviously color will be nicer, okay? So I leave that to you. That's, entirely your call. Make sense? But basically a function such as this converts a color image into a grayscale image. What do you think this one's doing? NumPy, right? Back to NumPy again. We always go back to NumPy, right? So we take the image and now you convert it into a NumPy array. And this is really great because you guys already know how to use NumPy and you understand that you can process and flatten and all that stuff. Ties back to some of the things we've done already. Okay. All right. Then over here, you can see the image name, which was this one, is passed to label function 2, which is the one I just described, that just takes all the values from the name and produces the conditions vector. So I have some things that were specific to my data set, such as if it's equal to TG, only use those. That's kind of what I needed to do, but you guys probably won't have things like that. Like if this, so notice that the function returns something that I called temp label vector RC, right? So that's basically that vector. And then I just looked at this TG. If it was there, then I'm going to use it. And then what am I doing? Basically, I have a list of images and I append to it the NumPy version of the image. And I have a list labels vector and I append to it the vector of conditions. Got it? Any questions on this part? So that's great because now you have a list of NumPy arrays and you have a list of, I think a list of lists. It's a list of lists. It's a Python native list. Okay, so that's what you have basically, right? We completed that. Notice that I did this because I have a tendency to always remind myself of what is X and Y. So I did that. I did do this train test split, although I honestly it's because it's instinct, but because we don't have a way of evaluating, right? We don't have a way of evaluating. Got it? Now, one thing actually that you could do is if you leave this outside test, this outside set, it's already annotated, right? So you could look at that image in the test set, look at the conditions in it, go to your app, enter those same conditions and hit generate. And it would give you an image, correct? So you could effectively compare that image to the real image and see how close it got to it. Do you see what I'm saying? Does that make sense? Yeah. So there's that. You can do that. It's kind of a way of corroborating. So for instance, if this image, these conditions, right, indicate a furnace that is really, really hot, right? But it never got this data for the generation. I can use the conditions, plug them in the application, and what should I expect of the generated image? I should expect that it should also be a furnace that is really, really hot. Do you see that? That's kind of, so there is a way of validating like that. Any questions? All right, so anyway, so I did that. So there is a valid, if you don't want to do that, you can just use all the data though, and then we'll just do like a qualitative analysis. You don't have to get into that. All right, so that gives you the X train, X test, Y train, Y test. Here I'm just printing things out. This is basically an image. I created these three lists and now I'm doing some further processing for index in range of length X train. Why did I decide to use the index? Because I have two files, right? Or two lists where in one I have the vectors and another one I have the images, but they're both 100. So that way by index, I can extract the conditions and the image. Or, you know, if I extract image 17, I'll extract conditions 17. Okay. So here you can see the index is being used. So start at index, let's say 1, 2, etc. Grab that one as reg vals. Remember, it's a list. So at this point, what's this one doing here? NumPy array, right? So now going into NumPy. Yeah, please.
Just allocates an array size 10.
Yes.
Well, isn't it technically a
Hmm?
vector?
Sorry?
Isn't it technically a vector on the MP zeros? Isn't it just like 10 by 1 or whatever?
Yeah, this target.
Mhm.
Yeah, I'm creating initially a vector of all zeros of size 10. Yeah, I just there's better ways of writing this code. So you guys,
It's like a 4 with 2.
huh?
Or like a 4 with 2. Target 0.
Yes, exactly. I have a tendency to make things very obvious, but not sometimes, yeah, not super efficient, because then I have to spend like, what was this for? You know, I don't want to do that. So
Then there's 1,000 size.
no, right, then I have to do it. But in things like this is just super obvious to me. All right, so anyway, all I'm doing is converting it to NumPy. I could have converted this in some other way, but when I do things like this, it's because, you don't always want to be quick about what you're doing. You want to make sure you do it right. You know what I mean? And so I'm always, and this is me checking that I'm doing this right and I didn't make a mistake. All right, so anyway, you assigned, plus also there's some kind of a different in the indices because of the file name and so on, okay? But anyway, all this code, all it does is creates a NumPy array with the values. X train index is what? The corresponding image. Notice that I called it single NP image, all right? So now I have an image and I have the conditions vector. And I'm adding these into these lists again, okay? I'm doing these lists again. So basically it should, single image is the thing that I really care about, okay? So that's images train. That one we need for sure. And then I have this one, IDs train and features train. So regvals 0. Oh, regvals 0. What would that be? Regvals 0 is the file name, I think. Right? Wasn't it the file name? So that's what's in there. IDs. That's why this is called list IDs train. I'm keeping track of the ID, which is the file name. Do you guys see that? Right. If we go regval 0, regvals, we did it here. So yeah, regvals is this, where 0 is the because you know, one was this TG, so really that it's this one, the file name. See that? So it's the indexing thing that I'm trying to map. You could, as I said, it's not so complicated, so you can write your own version of this. All right. Once this is done, where were we? So we have these three lists, right? List images train 0. This is just one image, right? You should agree, a NumPy version of it. Now we are going, we've done that. Didn't we do that? Wait, hold on. Regvals. Oh, sorry. This is, if you notice, the only difference here, X train, repeated code, X test. So it's doing it for the train set and the test set, but it's the exact same code. As I said, for you guys, since you're not going to be evaluating with a metric, you can probably disregard this one, get rid of it even, and just generate for the train, okay? All right, great. So that takes care of that. Now we end up with list features. List features. Okay, so this one, list features train target, that contains the conditions. Images contains the images, and IDs contains the file names. So now these are converted into NumPy arrays. I printed this conditions. Notice that I did now call it conditions main matrix train and printed the shapes. So you got 668 by 10. Always print the shapes. That's a very good practice. Is it making sense? That's it. So we're almost done, right? We're almost done here. At this point, save data for deployment. You're going to generate your CSVs. So conditions matrix train. This is pandas. Pandas data frame takes in conditions matrix train. So this is very common in machine learning. We go from lists to NumPy to pandas to torch, NumPy, pandas. It's a whole mix of switching from one format to the other. But I take conditions matrix train, run it through the pandas library, and now I create the data frame conditions train, okay? And at that point, I can use data frame conditions train to CSV. And literally at that point, you've got your file that will go on GitHub and can be accessed from the app. Does this make sense, guys? One important thing, if you notice, I didn't put an ID here, and I suspect it's because pandas has a tendency to add an index column. And so, although I didn't print this out, you guys should print the pandas frame, and you will see it probably added that column of index, and I just use that for the indexing because it's going to be consistent for both. Does that make sense? So this is an important thing, okay? Print, please, df train. I just kind of have remember this, and so it probably just added that, and you can use that for the index. So it's even easier in that sense. Since then I created this other file, which I think I'm not using in the code in the end. List IDs train. That's probably the reason, because once I realized that the pandas frame had done it, I realized I didn't need to do. All right, so but here you can save that file as well. That's done. List IDs train. Here's an image. I'm just doing checks. I suggest you guys do too. Okay. List images train stretch. So what does this tell you about each image in that NumPy? They're currently two-dimensional, correct? They're grids. They are in fact 140 by 39, but we're not gonna save them like that on the CSV. What do we need to do? Spaghettify them, right? Or flatten them. And you guys, some of you, when you did your reshape homework, you had this solution, right? The -1. So basically then, this just does for the image NumPy in list of images train. So basically that list contains all the NumPy images, but two-dimensional. And now it's going to generate, this is a list comprehension. It takes those lists and spaghettifies. So now you have them, if they were 28 by 28, now they're going to be 784. Got it? Any questions about that? Okay. So remember, so the name is list images train stretched, okay? Now I printed that and you can see it is now a vector instead of being a matrix, okay? Print the shape, there it is, 5460. Also do this to confirm. That's why I said shapes are really very handy. Here, because this is 5,490, I just kind of wanted to see it. You know, this is another check. What is this called? Slicing, right? You see it all the time. And this is indexing, and you should, you know, it's important. Another example, just ran that. Okay. Keep scales at 0 to 255, so the images are this. So now let's so now I take the list of images train stretched, and I once again, because it's a list of NumPys, convert it into a whole NumPy. Do you see that? Instead of being a list of NumPys, I want a NumPy again. That creates NP list of images train stretched. Print the shape, 668 by 5460. 668 images of all the pixels that are 5460. That's it. Once again, I printed one. And now I take this one, right? NP list images train stretch, which is a NumPy, and I run it through, what's this one? Pandas. And Pandas is the library. It's a very powerful library. Like all of Excel and SQL, everything that you've learned in SQL about joins, inner joins, and all that, and all the things that you can do in Excel in one Python library, which is called Pandas. You see that? So it's really powerful. So it creates the same thing, but now it's a data frame. So data frame images NP train, and you can see now I printed the data frame. So this is a pandas format. You can see. Oh, here, yeah. So there's the index, right? You see the index right there. Does that make sense, guys? Okay. And now you just, because it's a pandas frame, a data frame, so you just do 2 CSV and it creates your CSV file. That's it. So we've run, this is only the steps that you have to follow. Here we generate 3 CSVs. They will go into your repo plus your index, and there you go. And you can do your project. So really you have everything except the images, which you need to collect and resize, and then the annotation scheme, which it's going to be very dependent on the problem that you're trying to address. I think start with a simple problem, annotate about 30 images with a few conditions, see how that works, and then iteratively improve upon it. Any questions? The rest of this, if you notice, it says follow web tool logic. So what I'm saying here is what is in the index HTML file, I decided to kind of try it out in this Jupyter to kind of view it. So I'm not going to cover that part, but I'll let you guys play with it. It's just the same idea. Okay, that's it. So it's 7:40. I'm going to stop the recording.